From the CPRE Knowledge Hub and cprehub.org, this is Research Minutes, a deep dive into new and important research in the realm of education. Today, we look at a new study of urban mathematics instruction, which set out to determine how, and how well, teachers are implementing reforms that have been championed by researchers, policymakers, and other stakeholders over the past 20 years.
My research team and I were watching a lot of 4th and 5th grade classroom mathematics videos for a study we were working on. But along the way, things were looking different than the typical portrayal of U.S. instruction. Teachers were doing a lot more of the things that reformers wanted to see and that reformers had been working on for the better part of 2 decades.
We welcome Harvard University researcher Heather Hill, who recently led an observational study of 5 urban school districts to understand the real-world application of reform-aligned instruction.
We found that the district that had the most reform-aligned instruction, the ones where teachers were doing the most sense-making, the kids had the most opportunities to do cognitively demanding work, that district had been at math reform for over a decade. And so creating that alignment was really, really important.
That's right now on Research Minutes.
I'm Caroline Ebby, Senior Researcher with the Consortium for Policy Research and Education. Today, I'm happy to be joined by Heather Hill, the Jerome T. Murphy Professor in Education at the Harvard Graduate School of Education, and lead author of the new study, Learning Lessons from Instruction, Descriptive Results from an Observational Study of Urban Elementary Classrooms. Heather, it's a pleasure to have you.
Yeah, thanks, Caroline. It's delightful to be here.
So I wanted to begin by asking you to describe what led you to write this paper and what you were hoping to find out.
So this paper came about because my research team and I were watching a lot of 4th and 5th grade classroom mathematics videos for a study we were working on. We had usually between 3 and 9 videos for about 300 teachers, and we were really in the weeds trying to figure out how to code various aspects of mathematics instruction reliably for later analyses that we wanted to do down the road. But along the way, we started talking about how things were looking different than the typical portrayal of U.S. instruction. So almost 20 years ago, we had the Timmons Report come out, and the Timmons Report was a video study of middle school math. And there were other studies of the same genre looking at videos of U.S. classrooms. And what those all typically said was, well, math instruction in the U.S. is often very procedurally oriented. It's direct instruction. Kids are listening, then they're practicing, then they're moving on. And what we were seeing in this data set that we were looking at in 2014, 2015 was that teachers were doing a lot more of the things that reformers wanted to see and that reformers had been working on for the better part of 2 decades. So for instance, there was a lot of more mathematical sense-making in these classes than earlier research had suggested. With sense-making meaning, the teachers giving kids opportunities to make sense of why things are true in mathematics or how the solution procedure relates back to the problem. There was also a little more in the way of cognitively demanding instruction, in the sense that kids were engaging in mathematical practices like asking mathematical questions and engaging in mathematical reasoning. These are essential components of the math reforms over the last 30 years, and it seemed worth writing about. You've been in policy research for a while, and you know that there are not that many policy wins out there, and it seemed worth recording this one.
Great. So can you talk a little bit about how your research design was different from past studies that have looked at this question?
Yeah, so our sample was not nearly as nice as the Timmons sample. The Timmons was the 3rd International Mathematics and Science Study, and they did a video sample. I think it was about 90 classrooms in the US, but they had classrooms from all over the world. But the feature of that study that was so cool was they used a nationally representative sample, meaning they scientifically chose the classrooms that would be in the study. Our study was more observational in the sense that we were looking for teachers who would be in the study for up to 3 years. We were looking for teachers that came from the same districts so that we could learn something about how district influences played out in teachers' instruction. And we also used a different observation rubric. So the Timmons observation rubric, when we took a look, was 200 pages, and we sort of threw our hands up in the air and said, we can't do that. And we ended up first at Michigan and then at Harvard later developing a separate observation instrument known as the Mathematical Quality of Instruction.
Can you talk about some ways that your observation rubric was different?
So our observation rubric has 3 dimensions, one of which is very similar to Timmons in that it is the cognitive demand of student work. So are students asking questions? Are they reasoning mathematically? what's the cognitive demand of the task. And Timmons certainly captured quite a bit of that. The other two dimensions are a little bit less aligned with Timmons. One is richness of the mathematics. And there we're trying to capture the extent to which there's meaning in the mathematics that kids are presented with. Whether it's kids doing the meaning orientation and the kids are building the meaning, or whether it's the teacher actually providing the meaning or providing mathematical explanations. That's also where sense making fits in. And we also measure several mathematical practices like developing generalizations. The third element, or the third dimension of the MQI, focuses on little mathematical imprecisions and errors and lack of clarity that occur in classrooms, and that, if not corrected, kids can develop misconceptions from. So a typical example would be a classroom where a calculation 8 plus 4 equals is presented as just, this isn't a signal to compute, rather than the equal sign, meaning you're supposed to be balancing the quantities on both sides of that equal sign. And when kids see the equal sign as an indication to compute, they develop problems that lead them to have larger issues when they get to algebra in later grades.
Interesting. And you looked at 5 districts, is that correct?
That's correct. We looked at 5 districts, and I think we had at least 30 teachers in each district.
Great. So let's jump right into the results. What did you discover about the quality of math instruction across these 5 districts?
So we found that teachers in the sample do use reform-aligned instructional practices, but they do so within the confines of traditional lesson formats. So whereas a lot of the reform orientation had been to turn math lessons and math classrooms into investigation spaces where kids are working together collaboratively on problems that are novel and then come back together to have a discussion about how to solve those problems with teacher input. We found that teachers were actually adapting the reform in ways that fit direct instruction. So for instance, when they were asking kids to solve more cognitively demanding problems, they did so for a relatively short period of time, like a think, pair, share, rather than a 10 or 15-minute investigation. When they were asking kids to develop mathematical explanations, they would do that in a sort of back and forth format that wasn't typical inquiry response evaluation format, which people think about as direct instruction. They were doing that instead in formats that, the teacher would talk, the kids would then talk for a while, then the teacher would talk for a while, then the kids would talk for a while. So the teachers weren't giving up their role as the center of the math classrooms, but they were weaving in many, many more opportunities for kids to think hard about the mathematics and to gain access to the meaning behind the mathematics.
That's really interesting and seems very important. In your article, you present both quantitative data and also detailed case studies to provide a really rich picture of what the typical math instruction looked like in those classrooms. And you talk about, I think you divide them into classrooms that were rated at the 90th and the 50th and the 10th percentiles on your measure of instructional quality. Can you briefly describe some of those differences that you found?
Sure. And this goes to actually the variability we saw across the sample and how teachers were implementing math reform-ish kinds of instruction. So at the 90th percentile, we found that teachers were focused on mathematical practices and sense-making. They often heavily involved kids in, quote, doing the work of the lesson. For instance, we profiled one teacher who was working on representing real-life situations with variables. And she said something like, Robert had 15 pieces of chocolate. He ate some and now has 8 pieces left. How much chocolate did he eat? So this sounds like a second grade subtraction problem, but what the teacher was actually trying to do was to get kids to write out an equation that corresponded to that story problem. And she said, what I want you to do is write the equation. I want you to tell me, don't answer the question. You're going to write an equation that fits this situation and tell me what that variable stands for. Okay. So she's asking them to do kind of a little bit of a stepped up cognitively demanding piece of work. And she's actually also asking them to make sense both of the variable and the story problem and how they connect to each other. So that is exactly where we saw a lot of the instruction in 90th percentile lessons. Seldom did we see classrooms fully turned over to student investigation and discussion. Instead, the teachers were actually providing shorter, more directed opportunities for kids to think and reason. So at the 10th percentile, this is at the bottom of the distribution of teachers, we actually did see some meaning making and student reasoning there, but it was much more brief than we saw in the 90th percentile at the top of the distribution. Other times we saw students sitting and watching teachers provide information. This was very similar to direct instruction and what was found in the Timmons Report. And we also saw frequent muddling of the mathematics. So a teacher explanation wasn't quite right, or the language that the teacher used to describe a mathematical phenomenon wasn't quite accurate from the perspective of mathematics. And then surprisingly, we saw a lot of slow-paced lessons. And it wasn't because the class was having a deep discussion about a mathematical topic. It was just that the class moved very, very slowly through the content. And so not a lot of content got covered in those classrooms in some cases. So with the 50th percentile, there were two different profiles. One was just teachers who were using mostly direct instruction, teaching procedures to their kids. And another profile was teachers who had a mix of things, some elements of nice meaning making and student cognitive demand, but also some lack of clarity in the mathematics they were teaching to the kids.
So one of the things I really liked about your article are the detailed descriptions that you provide to show what math instruction looked like in these different types of classrooms. You also looked at connections between district reform strategies and instructional practice. What differences did you find across the districts, and how would you explain those differences?
Yeah, so we saw, even as we were just watching the video initially, we could watch a video and almost tell you where district that video was coming from, not only because the curriculum that was in use in these districts was different, but because the style of instruction looked quite different across the district. We found that the district that had the most reform-aligned instruction, the ones where teachers were doing the most sense-making, the kids had the most opportunities to do cognitively demanding work, that district had been at math reform for over a decade. So the math coordinator in the district, the K-8 math coordinator in the district, had come in and she had a plan, and she pursued grants, she got people on board, and she executed that plan over a very long period of time. And what that looked like was the district very carefully coordinating instructional guidance. So for instance, picking a standardized aligned curriculum, so a curriculum that they felt reflected the progressive standards in their state, offering professional development around their standardized aligned curriculum and in support of this vision of student learning that they had. And even routinely talking to principals about how those principals could support teachers in improving those teachers' instruction. So, when you walk in a classroom to do a quick observation, we're expecting you to see X, Y, and Z. You might ask the teacher this kind of question. So this was really interesting to us because, as you know from studying policy in the US, it's very unlikely that a district can hold together a coherent reform effort over such a long period of time. But we believe that sort of coherence and the length of time led to higher quality instruction. We don't have pre-post data from before and after this effort, but we could see that this kind of high quality instruction was less present in other districts. It was more kind of pop-up. Some teachers had it, but most didn't. That in this district, we saw more consistency in the quality of instruction.
So you're starting to get at this, but what do you think are the main takeaways here? What are the implications for, say, policymakers, practitioners, and other stakeholders?
So I would say number one is persist and, provide resources to district math coordinators, to other people who are involved in this effort to make it work. As you know, there's no quick fixes in improving instruction. It's not something that happens overnight. It's probably very much resembles other incremental processes across the board. So sticking with it and, making sure that all the conditions are there and all the resources are there for reform to happen is really important. One of those really important things, I think, is aligning the curriculum materials to the professional development and, if possible, to the assessment. This particular district that was so successful actually had a very progressive state assessment in which kids were writing open-ended responses about the mathematics. So you could see that the district math coordinator could say to the principals, look, if you stick with me, kids are going to be doing better on the state assessment. And that was actually true. And so creating that alignment where the curriculum materials and the professional development are supporting this sort of progressive assessment was really, really important.
Those seem like really important lessons. Heather, are there other directions for future research that you hope to pursue?
So we've actually just, because we love doing this so much, we started a similar line of research with middle school teachers. And we're finding the same thing. We actually went and we applied to have the Timmons data come into Harvard. And this is, it's a super secure data room and they come and they inspect at random times. So it was kind of a production to get the Timmons data in, but it was fascinating to watch and score the Timmons data. And, everything that Jim Hebert and Jim Stigler wrote about the Timmons data, I think is completely accurate from having watched the data set. It was fascinating how well also they captured the nature of US instruction on 99. But what we saw when we looked at the middle school data that we collected in 2016 was that things actually did look a little different in middle school as well. So there was a little bit more sense-making and mathematical richness in those classrooms and a little bit more cognitive demand, but again, within a direct instruction format. I owe that paper, though, so you'll have to wait maybe a year before you'll see any results out of me.
Well, we will certainly look forward to that. Well, Heather, I just want to say that this is a fascinating study. And for those who would like to learn more, I encourage our listeners to read the full article in Teachers College Record, available at tcrecord.org. Heather Hill, it's been a pleasure talking with you.
Thanks so much, Caroline. It was a pleasure talking with you, too.
Thanks for listening to this week's Research Minutes, presented by the CPRE Knowledge Hub. For more episodes, or to subscribe to this series, visit us at cprehub.org. That's cprehub.org.